he is important enough for a recording. I'm just saying it will benefit more than just Sartell. Anyway. Okay, guys, so pay attention. Okay, so basically, you really need to see a function graphed in order to understand what I'm getting at. Okay? Now, a limit is the value of the function, meaning the y value of the function, as the x value approaches a certain number. Okay? So here we are. We've got one of the nastier functions right here. Okay? We've got the limit as x approaches, and this, like a square root. So yes, this down there is the square root of 9.
Whoa.
3 minus 3 is 0. Whoa.
Which is
right?
Isn't this a different indeterminate than like 1 over 0?
Yes, it is. Very good. This is called an indeterminate form because really, like conceptually, what is 0 divided by 0?
You're trying to put
No lie, if you ask Siri what 0 divided by 0 is. See, yes. Imagine you have 0 cookies and you are sharing them among 0 friends. Well, that does not make any sense. Like our division problems from 3rd grade, you know, you had your little counting bears or the little counting cubes or whatever, and you did 8 divided by 2 and you scooted by 2s, you know. Well, if you have, hey guys, if you have 0 items and you divide them into 0 groups, that doesn't make any sense.
Nothing has happened.
Or if you have 30 cookies and you divide them into 0 groups,
-1.
doesn't. Okay, so the very basic idea here is that you can't divide by 0. Period.
Well,
right?
I mean, you can, but it's just really stupid.
You can't because it's indeterminate. And 0 divided by 0, I hope in your mind you're thinking, well, is it 0 or is it 1? Right? Is that what's going on?
Or it could be any number.
Very good. It is indeterminate. It is neither 1 nor 0. It is indeterminate. It don't make sense. Okay? Now, that is why the graph has a hole in it. But the limit as x approaches 9 from the left of x minus 9 over the square root of x minus 3 is the y value that this gets super close to when you get closer and closer, well, wait, from the left, as the x value gets closer and closer to 9. Well, actually, what is that? Is that,
6.
let me look on my, oh no.
Yeah.
Is it 6? If that right there is 6, then the limit as x approaches 9 from the left is equal to 6. I'm actually going to double check that when I do it algebraically here in a second.
It's weird when you do it algebraically.
So I have some tips for that. And anyway, the value of this function is not 6, right? Because, like, if you plug in a 9, you're going to get 0 over 0. How the hell did you get 6 from that, right? So, but the limit as x gets closer and closer to 9 from the left, like, if I were to plug in the number 8.99999, then my table, my table of values would end up being 5.99999. right? And I can see that just from the graph. Yes.
So wouldn't it, like, if it was x approaches 9 from the right, would it still be 6?
Yes, it would. Yes, actually, this one is the same because it's approaching the same value from the left as it is from the right. So actually, I can drop that negative there. That means from the left. The limit of this function as x approaches 9 is 6. The value of the function is not 6. The value of the function is 0 over 0.
Wait, so it's just that's
Yeah.
Well, graphically, that's it. Now-
Algebraically, you can just keep putting in values closer and closer.
That's analytically, but algebraically, something cool can be done.
this way.
It is, yes.
So even if it's approaching like from the right, isn't it always headed towards that x value then?
It is headed towards a certain y value as we head towards a certain x value. Yes.
So,
Yeah.
I mean, I guess I'm just kind of confused on the concept of it. So it's got negative 9, and then the limit there is 6. So and then it has that little symbol there, like it's not.
Because the value of this function
At negative.
at 9 is damn near 6. It's not touching 6, but it's really, really freaking close to it.
Okay.
Does that make sense?
Yeah.
Okay, well, before I ask if this makes sense, let's think algebraically. Okay, this is just bad form anyway, because we have a radical in the bottom. Now, as far as an answer, a radical in the bottom is fine. We no longer, freak out about that. But if I said I wanted you to rationalize this, what would you do? We would multiply the top and bottom by the conjugate of the bottom. Now, what is the conjugate of that denominator there? Square root of x plus, the square root of x plus 3 and the square root of x plus 3. Okay, guys, are you looking? Do you understand that I'm multiplying by the conjugate? You might not understand why just yet because, oh crap, look at that stuff on top. It's
One of the things we did on Dalton Math at the start of the year.
Square root of x plus 3. And you know what? I don't think I'm going to distribute that. It'll make sense here in a second, okay? What do I get on the bottom?
You get don't you get x minus 9?
You get x minus 9.
Oh,
Root
wait,
x
and then
plus
those?
3.
Wait, no, wait.
Yeah?
Oh.
Yes.
Oh.
Hold on a minute.
Square root of x times square root of x is x.
And then those cancel out.
Then plus 3 radical x minus 3 radical x and then minus 9.
Oh.
So the fact that I left the top factored, I knew this was going to happen. The fact that I left this factored now lets me cancel those out. So this function is equivalent to just the square root of x plus 3. Now plug 9 into that. What will you get?
Oh my God.
The square root of 9 plus 3 would be 6.
You can't do that. Wait.
You can.
What?
You can. Now, admittedly, what I've just done here is I've canceled out a situation where a factor on top is the same as a factor on or the bottom, period. You guys, when you do that, you will have a hole in the graph, which makes sense with our graph sitting right here. There is a hole at x equals 9. But the limit, because of our algebraic manipulation, the limit would be equal to 6.
That was
Okay,
cool.
more when we come back from lunch.
You did it.